Let's talk about a join type that hasn't really been in any SQL databases until very recently. Because this join type hasn't really been popularized that much, it doesn't have a consistent name. So in the DuckDB database, it's called the positional join, and in ClickHouse, it's called the paste join. They both do more or less the same thing. I'll explain the differences later on. But you won't find this type of join in most other databases. As far as I know, DuckDB and ClickHouse are the only two SQL databases that support this kind of join. So if you know of another SQL database that also supports this type of join, please let me know in the comments because I'm curious. I've just gone and called it the glue join because all this really does is it glues two tables together. The intuition that you should use for most other joins in SQL is that it's a lookup. But a positional or a paste or a glue join, however you want to think about this particular type of join, this one literally just glues two tables together. It's kind of like a union, which glues the two sets of rows together, but on the other axis. It's literally taking two tables and gluing them together side by side. To help illustrate this, I've just got two very simple tables. We've got a table of words, which has two words, hello and world, and a table of numbers, which has three numbers, 1, 2, and 3. Easy peasy. This example is going to be in DuckDB. So let's go ahead and see what happens when we do this join in DuckDB. So we'll select everything from, we'll start with words. We will positional join onto numbers. And let's see what we get. So I'm going to give this a run. It does indeed just glue the tables side by side. Now the numbers table's got 3 rows and the words table has got 2 rows. So what DuckDB has done here is it's kept all of the rows across both tables. And for the rows that are missing in the word table, it's just gone in and whacked in a null. This is DuckDB. And this is where DuckDB and ClickHouse would differ. DuckDB keeps all rows and adds in nulls for the rows that are missing. But ClickHouse would only keep the number of rows that exist in both tables. So in ClickHouse, it would drop this last row because there's no row in the words table for this number to be glued up with. So that's one really important difference between the way that this join type is implemented in DuckDB versus ClickHouse. Let's go and prove that ClickHouse does indeed drop this row. So we're currently using DuckDB. I'm going to switch this over to ClickHouse. And let's just rerun the two of these just to make sure that we've got the same data. We sure do. For ClickHouse, we don't write positional. That was the word that we used for DuckDB. Instead, we write paste. And now when we give this a run, we do indeed only get 2 rows in the output. There was no row in the words table for the number 3 to be glued up against. So in ClickHouse, it doesn't show that 3 whatsoever. In DuckDB, it would just use null for word instead. The natural question is, what's the point of these joins? Why would you need a positional join or a paste join? And I've brought up the DuckDB documentation because it highlights the reason why positional joins are helpful. If you're not used to DuckDB, one of the really convenient features that it has is that it's really easy to read in other file types like CSVs and Parquet files into DuckDB. Now CSVs and Parquet files do have a natural order to them. So part of what you're doing may be that you need to read in several CSV files and then join them on their row positions. Without the positional join, you might need to use the row number window function to give each row a row number, a specific individual row number, and then do something like a left join or a full join in order to join your CSV files together. But with a positional join, you don't need to bother with that. If you know that the CSV files have a natural order that you want to exploit, then you can just join them on the row order. So let's actually do some of this. Let's read in some CSV files and do a positional join on them. Now this is a slightly adjusted version of a real example of something that I had to do in my job earlier this week. The scenario is customers adding items to a shopping basket. And for various reasons, the items that they add, the list of items that they add, goes to one place, we'll say one CSV file, and the corresponding prices for those items go to a different list, we'll say a different CSV file. This is a little bit annoying, but it was the situation that we were in. Now in my case, and in this case as well, we can assume that the item IDs and the item prices are in the same order in these underlying CSV files. We'll say that this is operationally the case, because if somebody adds an item to their basket, then both of these lists get updated at the same time. We'll keep things simple and say that that's a valid assumption to make. So let's take a look at this data. So we've got some basket items, and in DuckDB, this is how you can read in a CSV file. You literally just write the file path to the CSV file. So in this particular case, we've got a basket ID and the items that they had. Similarly, in basket prices, we've got the basket ID and the corresponding price. So I can see that item 3228 has a price of 59 pence. 4530 has a price of 129. In our case, what we wanted to do was join these together so that we had a final table that had basket ID, item, and price all together. So equipped with positional join, this is super easy to do. All we need to do, I'll just make my life a little easier. I'm just going to copy this one down. We select everything from basket items. We'll call this one items, and we just do a positional join on the prices. We'll call this prices. So if I give this a run, we now have the basket IDs and the items and the prices all together. Of course, we could adjust our star to only keep one basket ID. In my case, I wanted to keep it both because I wanted to validate that the basket IDs were indeed the same for every row that we paired up, but it's totally up to you. How might we do this without the positional join? Well, like I said earlier, I think we would just want to use a row number window function just so that we can get some row numbers in our individual CSV files and then join them up that way. So let's give that a quick go. So if it was me, I'd do set up some CTEs. So let's grab the two of these and let's whack in a row number. Now I don't want to change the order of the CSV as it is, so I'm just going to order by null. I'm pretty sure that that doesn't change the underlying order of the table. So we'll call that row number. Then let's also bring in the prices. So we're going to do prices, and then we can do a join. We can do a select star from items. In this case, I would want to do a full join. That's most similar to how DuckDB does a positional join. This time we'd want to do it on prices using the row number. And because I don't care about the row number in my output, we can do the exclude row number. So that when we give this a run, we end up with the same thing. And let's just check. So 3228, 4530, 8992, blah, blah, blah. 0.59, 129, 189. Looks good to me. But this is not as nice. And also it assumes that order by null does indeed not change the order of the CSV. There would be other approaches as well, depending on the database that you're using. If you save the CSV data into an actual database object, an actual database table, you'll then have quite often a row ID pseudo column that you can join on. We're constructing our own one with the row number window function, but there's sometimes a built-in row ID that's implicitly added to all physical tables. But this just isn't as nice as using the positional join. It's so much easier just to use the positional join without having to manufacture any row numbers that we know we're going to want to join on. I've said a few times in this video that CSVs have a natural order. So you might be thinking, well, don't SQL tables have a natural order as well? So all I'm going to illustrate now is how the order of rows can change in a SQL table, specifically a SQL Server table, just by doing things that we might not think would change the output order of the rows. Just to really illustrate that, like, SQL databases make no guarantees about the order in which your rows are going to be returned unless you put in an explicit order by clause. And that's why explicit order by clauses are so important if you want to guarantee the order that your rows are going to be returned in. So let's take a look at this table here. This is a SQL Server table. We're using the AdventureWorks database, which is quite a popular SQL Server database. And the particular table that we're going to use for this example is the department table in the human resources schema. So if we just do a select star from this is what we have. Department ID, name, group name, and modified date. We've got quite a few departments in here. There's a few indexes on this table. The important one is that there's a clustered index on the department ID because it's the primary key. So what that usually means to people that understand a clustered index, what that usually means is that physically the rows are stored in this order, in the order of the department ID. This is convenient for many reasons, but that order doesn't necessarily stay the same when we start to use this table. So for example, let's do exactly the same query, except instead of keeping all of the columns, let's keep the department ID and the name. So I'm going to give this one a run, and already the order has changed. The order of the rows in our result set is already different than the underlying order of this table. We haven't done any operations. We haven't done anything except only keep 2 columns, and SQL Server has changed the order of the results, or changed the order of the rows. Another example, just to really reiterate this, where we might not expect this. Let's say we do keep everything, but we add a row number. Let's do a row number over, and we'll order by the group name. That was the group for the department. Let's give this a run. This time we are keeping all rows, we're just all columns, sorry, but we are just adding an extra column. If we give this a run, again, the order has changed. The rows in the result set have changed. By default, SQL databases will not guarantee an order to their rows unless you explicitly ask for them to with the order by clause. This is why the positional join for a lot of people just doesn't really make sense, because the assumption has always been, the understanding has always been that a SQL table can have whatever order it wants. So keep that in mind when you're working with the positional and the paste joins, and when you're working with SQL databases in general. So to wrap up, we've seen that there's this special type of join that's called positional in DuckDB and paste in ClickHouse. It's useful for just gluing 2 tables together by their row positions. This is quite a new join because SQL databases don't usually guarantee a row order. So joining by the row order doesn't necessarily always make sense. But in our particular case, we saw that places where it does make sense is joining something like CSV files, which do have a natural order that we can exploit. This probably isn't a join that you're going to use very often, but it's just a handy one to be aware of on the off chance that you might need it. But I hope you found this helpful, and we'll catch you in the next one.